So in this question here, we're given the equation of y equals x to the power of 4 minus 18x squared. And we want to find the coordinates of the stationary points and find out if they are local minimums, local maximums, or saddle points. So that's what we're looking for. So this question is all about derivatives. So a stationary point will be set when the derivative equals 0. So let's find the derivative of this equation and see if we can find its stationary points. So what we now need is dy dx. So the derivative of y with respect to x. So using the power rule, because these are all polynomials, x to the power of 4. So we keep our variable x and we now multiply this x by the power. So that becomes a 4x, and then we reduce the power by 1. 4 minus 1 is 3. And now the same here. So this time we've got a coefficient. So this time we've got x squared. So now we multiply by the 2. So we've got 2 times 18 is 36. And then we drop the power by 1. So that just becomes x to the power of 1, which is x. So that's our derivative. So now what we need to do now is set dy dx to be 0. And then we solve for x. So now let's factor out an x. So we got an x. And I can see here my coefficients also divide by 4. So I can bring out a 4x. So 4x. So now 4x factored out from x cubed gives me x squared. And then subtract, divide this by 4x, I've just got minus 9. So now we set that to be 0. Okay, well, I can see what's going on here now. I've got 4x can be 0. Or I've got x squared minus 9 equals 0. So in this occasion here, x equals 0, that's the stationary point. So let's write them up here. So stationary point, as which there is going to be at least, well, there's going to be at least 2. So x equals 0, that's 1. Now I can find my coordinates, so I can find my y coordinate in a moment, that will come up. Now x squared minus 9, let's solve for that. So now I'll have x squared equals positive 9, take the square root on both sides, so x equal plus or minus 3. So I've got x equals positive 3, I'll find the y in a moment, and x equals negative 3, we'll also find the y in a moment. Okay, so that takes care of that. So let's take these bits of working off here, and now we can find if it's a minimum or maximum or saddle point, we need to find the derivative again of this equation. So let's take this off the board. Okay, so let's find the second derivative. So d squared y, that's the second derivative of y with respect to x. So second derivative, it's the same as taking the derivative of the first derivative. So we will now have, multiply this by 3, so I'll have a 12. My x will stay, and drop the power by 1, I've got 12x squared. And now I've got minus 36x, well, I've got x to the power of 1, times everything by 1, so that's still 36. Drop the power by 1, that becomes x to the 0. X to the 0 is just 1, so that is my second derivative. Okay, so this will tell me what my nature of my points is. So let's use this to find out what's going on. So if x equals 0, let's plug in what happens there. If x equals 0, I've got 12 times 0 minus 36. So 12 times 0 is 0, minus 36, I've got minus 36. So if my second derivative is negative, so my second derivative here is negative, that means I've got what's called a local maximum at 0. So this one here will be a local maximum. It's called a local maximum because it might not be the maximum value of the whole graph, but in that region of the graph, that's a local maximum. Okay, now let's see what happens when x equals plus 3. So now 12 times 3 squared, and then minus 36. Okay, well this is going to be positive, isn't it? Because 3 squared is 9, 9 12s 108, 108 minus 36, that's going to give me 72. So that's going to give me a positive value. So therefore, when I've got a positive value for my second derivative, that's what's called a local minimum. So at x equals plus 3, I've got a local minimum. Okay, now let's see what happens at x equals minus 3. So that's going to give me 12 times minus 3 squared minus 36. Plug it into the second derivative. Well, minus 3 squared is 9, times 12 is 108, minus 36. It's got the same value as this derivative here. So that one is also positive. So therefore, at x equals minus 3, that is also a local minimum. Okay, so now all I need to do now is find the coordinates of y at x equals 0, plus 3 and minus 3. So let's do that. We'll do that here. So here, what I do is to find my coordinates, I plug that into my original equation because I just want the coordinates of the stationary points. So for x equals 0, I've got y equals 0 to the 4 minus 18 times 0 squared. So that is just going to give me 0 minus 0, which is just 0. So that's x equals 0, y equals 0. So therefore I've got one coordinate of the stationary point is at 0, 0. Okay, let's find the next one. X equals 3. So therefore y equals 3 to the power of 4 minus 18 times 3 squared. Okay, 3 to the power of 4, that's going to be 81. 3 squared is 9. 9 18s are 162. 81 minus 162 is minus 81. So therefore, I've got my local minimum there. X equals plus 3, y equals minus 81. So that looks good there. Now what happens at x equals minus 3? Y equals minus 3 to the power of 4 minus 18 times minus 3 squared. Well, minus 3 to the power of 4 is the same as 3 to the power of 4. And minus 3 squared and 3 squared are the same value. So that's going to yield the same value here. So that's minus 81. So here y equals minus 81 as well. So the coordinates of this stationary point here will be at 3, minus 81. And this one will be at minus 3, minus 81. Okay, and that's a good place to stop.